Hi guys, welcome to this video. In this video, we will be discussing about queue using stacks. So how can we implement queue using stack, right? So as we know, queue supports FIFO principle, which is first in, first out, and stack support last in, first out. So from the common sense, like it can be observed that if we reverse this principle two times, like first in first out, if reverse it will be LIFO, then again it will reverse, like then it will come out to be FIFO, right? So we need two reversals in order to satisfy this. So that's why also we need two stacks in order to implement this solution. Okay, so let's say our queue is 1 2 3 4 5, right? And if you need to implement the push operation, like we have two stacks, one stack is s1 and let's say one stack is s2, and if you push one, then one will be pushed. If you push two, then two will be pushed, and if you push three, three will be pushed. If you push four, four will be pushed to s1, and if five, five will be pushed to s1 only. Okay, so I hope this thing till now is clear. Now what we can do, like if someone comes and ask you for the top element, so top element is nothing but, let's say in the queue we have not top, we have front element, right? So if someone asks you, give me the front element, so what you can do, you need one, but at that stack it is five, so you need to pop the rest of the elements and push it into s2, like 2, 5 will be pushed, then 4, then 3, then 2. Then now what happens, my stack s1 will contain only 1, and you can return this element, right? And now when you, after returning, you can push back these elements in order to have the sequence which was earlier. Okay, and same with the pop operation, like if you need to pop element, like you can place the rest of the elements in s2, and then you can pop, and then again you can push the rest of the elements which was pushed in s2 to s1. Okay, so pop is clear, push is clear also, and size is nothing but size is equal to the size of s1, right? Because we are keeping the elements in s1 only, and s2 is getting used as a temporary stack. Now apart from this, if someone comes and queries you to print like if the stack is empty or not, then you can return size. Okay, size is equal to 0. So I hope the logic behind the problem is clear. Let's see its implementation. Okay, so I have written the class code and I have mentioned the member functions in it. So let's implement it one by one. So first of all, the push operation. So push operation will be having a integer which we need to push into the stack. So s1 dot push x, so it's simple. And if you need to pop the elements, and let's say you need to return also, right? So what you can do, while s1 dot size is not equal to 1, till the time only one element is left in our stack s1, we can pop the elements and push it into s2. So s1 dot top and s1 dot pop. Okay, now my s1 will be, my front element will be at the s1 dot top, because it's the last element only. And what I can do, I can pop that element. And after this, what I need to do, I need to push the rest of the elements, like while not s2 is empty. Okay, I can keep pushing it into s1, and finally, like here, there will be s2 dot pop, and finally what we can do, we can return x. Okay, so I hope the pop operation is clear. Similarly, the top operation will happen in the same manner. The only change here is that we don't need to delete the element, so this line will not be executed. Okay, so bool empty will be nothing but return s1 dot size is equal to 0. Okay, so if it is 0 then the stack is empty, otherwise not. And in the size function we can simply write return s1 dot size. Okay, so now let's implement our queue. Let's say we have 5 elements. So our queue name is queue using stack, and let's name it as small q. And we can run a for loop to take the input for int I equal to 0, I less than n, I plus plus, int x, scene x, and q dot push x. Okay, so I hope this is very clear. Okay, and now what we can do, if we want, we can print the elements of the queue. So while not queue dot empty, we can access the front element of the queue, and or it should be nothing but front. Okay, and we can pop the element. So q dot pop. Okay, let's run this, and we can see we are getting the output as 1 2 3 4 5 6 7. So I hope the logic behind the problem is clear and you enjoyed this session. Thanks for watching.